you all. Welcome to today's class. We'll be talking about the divergence theorem and the Stokes theorem. And if time permits us, we'll also talk about tensor analysis. If not, we can try and fix the time for us to do the tensor analysis. And that will be all for this class. Okay, without wasting much of our time, let me shoot from here. Can you see my board?
Yes, sir.
Yes, sir.
Okay. But what are the things we do in divergence theorem? We talk about the Gaussian smooth surface, and I'll give us the formula. Then from then we can now solve one or two example. Just look at one, then the way we solve it, and some of the criteria that we need to know when solving the divergence theorem. Divergence theorem. So let's look at the definition. At the definition, we have, I believe you still remember this symbol. Multiplied by f, vector f is div of f equals to the p, the x, plus the q, the y, plus the r, the z. So one of the theorems that governs this says, it says, we call it Gauss theorem, that is from the word Gaussian elimination. You remember Gauss? Gauss theorem says, let S be closed. Let S be closed piecewise, smooth surface which is the boundary of V with normal pointing outward. Then let F, vector F equals to P, Q, R belongs to C. C1 on a region, containing V, then we have here, then we have integral, surface integral, don't forget it's closed. This is the vector f, the x equals to the volume integral, depth vector for f, the x, the y, the z. Don't forget, in this case, we have our x squared plus y squared equals to r squared. You remember this one? And this will help us to be able to represent any question you were given. Most especially, depending on the surface you are dealing with. Okay, let's take, for example, this one now. If you have, let's take, for example, a cylinder case. Question 1 says f, vector f, x, y, z equals to 4xi minus 2y squared j plus z squared k. All belongs to C1. All belong to C1. That is in the region of C1. Then the now said S is the cylinder. S is the cylinder of the region x squared plus y squared equals to 4. Right. So, how do we resolve this? Then another boundary says 0 less or equals to z less or equals to 3. So we can go ahead and first of all resolve it before you put the, let's get the F flux first. But before then, let's look at the cylinder in the diagram first. So when you have a cylinder of this nature, and these are the things you can use to describe your solution, it will go a long way if you can do that. Of this, so let's say it touches a particular point. We call this point Z. Then we have our X here. Then we have our Y here. Remember, your S at the point of this is 3. Because Z is 0, between 0 and 3, right? So it started from the origin, which is 0 to 3. Then don't forget that we need to get what we call the X. Remember the way I taught you the last time how to get your, excuse me, how you get your range. So in this case now, what do we have? We have, recall that we still have this. Recall that we have x squared plus y. Our y squared in this case is what? Okay, we said x squared, y squared equals to 4. Then you agree with me, x squared is the same thing as 4 minus y squared. What is x? X is the square root of what? 4 minus y squared. Any question? Do we agree? I need a response, please.
Yes, sir, we agree.
You agree by fire, by force, or
By all means.
by all means? Which one?
Yes. We agree by all means.
You agree by all means, or you agree by mathematical? Which one you believe?
Mathematically, you are correct, sir.
Yeah. So don't just agree. Agree by mathematics. So because everything we are doing is still mathematical.
Hi. Oliver, hi.
Hi, how are you?
I'm good. How are you?
So in this case now, how do we get the other one? If you have the y to be this, how do we get the other one? Based on the method that I taught you. Can someone tell us? What are the things we need to do? I'm waiting. Yes, nobody. Nobody is talking. Are we there or we are sleeping? So that I will know whether my
Yes, sir, but
students
still.
are with me or not. You said something.
Yes, sir, I say we are here.
So what do we do from here?
That's what we are looking at now.
Now look at it critically. And tell me what once and for all, then we'll do it together. So any idea to move forward from here? If you think you have idea, just raise up your hands, then we can look at it together before I come up with my own solution. We are still on divergence theorem. So when you have this kind of equation, what do we do from here? Solving a divergence theorem. Anybody? Or should I be calling the name one by one so that you know that we are serious about this? I'm waiting. Okay, maybe you may not understand what we are doing. Should I assume that? I'm asking a question. Should I assume you don't understand it so that I can go ahead? Okay, let's look at it in this way. Remember, you have your x. Okay, this is what I will do. Let me give us. Okay, look at this question. We're coming back to the question one. Let's look at this question. Question two. Are we there?
Yes,
Evaluate.
sir.
Okay, evaluate. Let me give you us this. Let me use this one as intro. Evaluate integral x f dot n dx, where f vector f is equals to 4xzi minus y squared j plus yzk. and S is the surface of the cubule bounded by S equals to 0, S equals to 1, Y equals to 0, Y equals to 1, Z equals to 0, Z equals to 1. So how do we solve this problem? Once you see this, something will come to your mind. Oh, they are talking about divergence based on the definition of this. Look at the definition. So if I'm using divergence, it simply means I will do it this way. Solution. That's how you start by the divergence theorem. By the divergence theorem, the required integral is equal. The required integral is equal to integral the volume, the V, the F, the V, which is same thing as integral. What is the everything? Remember, dev means d dx, d dy, plus d dz. You remember? Am I talking, please? Hello?
Yes, sir, you are talking, sir.
So remember d dx of I, which is 4xz. Am I right?
Yes, sir.
Plus d dy of j, which is minus y squared. Then plus d dz of k, which is what? yz. Everything dv. So now that we know, what do we have to say? Integral of this, triple integral of v. So let's differentiate what is inside here with respect to what? X. What do we have? For what? When you differentiate this with respect to y, what do we have? We have minus y. You have minus 2y rather. Then when you now differentiate this with respect to z, you have plus y dv. So if you now want to solve this one, what do we have? We can resolve it triple integral v into 4z minus 2y plus y is y dv. So we have the limit. We can substitute the limit now. The limit says integral, let's say the first one is x. When x is equal to 0, the upper limit is 1. Then y equals to 0, the upper limit is also 1. Then when z equals to 0, the upper limit is 1. So what do we have? 4z minus y dv. dv ds is what? Since we substituted the boundary, we have it to be the z, the y, and the x. The z, the y, and the x. So what do we have to say here? So all we need to do is integrate the first time. What do we have? Let's keep the second. S equals to 0, 1. Y equals to 0, 1. Let's integrate what is inside with respect to z. We have 4z squared over 2 minus yz, making to be what? The y, the x. So here 1, here 2. So we have it to be integral of x equals to 0, 1, y equals to 0, 1. So you have it to be 2z squared minus yz, the y, the x. So don't forget the limits here. The limit is 0 to 1 because of z. The limit, if z is 0 to 1, what do we have? S equals to 0 to 1, y equals to 0 to 1. Substitute x. Substitute 1 where you have z. Upper limit minus lower limit, you have it to be what? 2 of 1 squared minus y of 1. Everything will be what? We still have it to be what? The y, the x. So this will give us what? When you integrate this one, so you have 2y. So when you have 2 minus y, then integrate it with respect to y. Now, what do we have? We are going to have, with respect to y, will be 2y minus y squared over 2. 0 to 1, the x. So what do we have in this case? Substitute 1 into it. So you have 0 to 1, then meaning you have 2 of 1 minus 1 over 2. So the x. So we need to integrate with respect to x. At the end of the day, when you integrate with respect to x, what do you have? You have 2x minus 1 all over 2x. So when you substitute 0 to 1, what do you have? You still have 2 minus 1 all over 2, which is equals to this is what? This is 2. 2 times 2, 4, minus 1 is what?
3 over 2.
3 over 2. Thank you. That is it. So it's just as simple as that. So I will do another one, and I want you to finish it up. But before that, remember we are working on a particular cylinder stuff before now. But it's pretty simple. You can see how simple it is to solve this particular problem. All we need to do is just to substitute the values. Then, if you now look at what you've been solving before now, I substituted this into it. I can go ahead. The final answer for it, I'll give it to you. But before I give you the final answer, I would need to explain some certain things to you. So let's go back to the equation 1, the first example. So the first example, I was trying to explain something. We have the first example to be, question 1 is to be f of x, comma y, comma z, to be 4xi. Am I right? Please check. minus 2y squared j plus z squared k. Remember, they both belongs to C1, the region of C1. Then it's a cylinder whereby we are talking about cylinder surface, which is C cylinder x squared plus y squared equals to 4. Then 0 less or equals to z less or equals to 3. So using Gaussian theorem that we did the other time, so what do we need to do in this case? Anytime you have, according to the Gaussian law, it says integral, double integral, which is surface. Remember, this is talking about surface in the cylinder. Then we have our f dot the x. It's still the same thing, the one we did the other time, equals to triple integral of v, which is depth of f dots the x, the y, the z. You remember now. So the way we solve it the other time is still going to be the same way. All we need to do is we can first of all resolve it in another form. For example, we have depth. Our f is what? Let's write f out, so that by the time we are referring to that f, we all be on the same page. Our f is of x, y, z, which is 4x (4xi) minus 2y squared j plus z squared k. Now, what do we need to do here? We first of all need to define this the way we did the other time. The p, the s, plus the q, the y, plus the r, the z. The question can be in different form. You can see this one now. So what is our the p? In this case now, which one will represent? This is our p. This is our p. This is our q. And this is our r. So it's pretty simple. Then we can differentiate with respect to x with p. We can differentiate with respect to y with q. We cannot differentiate with respect to z with r. So what do we have? It's still the same thing we did the other time. Remember here, we only put here. Remember what I did here. Just substitute x, the I, j, k inside this place. It's still the same thing. Let's say p, q, r. It's still the same thing. Take note of that. So PQR will be, so it's going to be d ds of what? 4x plus d dy of minus 2y plus d dz of z squared. So we have it to be 4 minus 2 . This is square, right? For y plus 2z. So this is what we have. So we can substitute this into our triple integral. Remember? The triple integral will be integral of this 4 minus 4y plus 2z. Then the x, the y, the z. But at this point, we need to change our variable and parameterization. We have to change of variable and parameterization. Because remember, because we are changing variable to cylindrical coordinate, because we are working on cylinder. So we are changing variables to cylindrical coordinates. Take note of that. In this case now, we now set lex x equals to rho of cos phi, and let y equals to rho of sine. Some can use sine theta. It depends on the way you want it. And our z will remain z in this case. So anywhere in this where we have this, we can now substitute it. So if you want to substitute it now, what do we have? We are going to have our integral, which we change, let's put our logo there, 0 to 3 for our z, when z is equal to 0 to 3. Then the second one will be what? But because we already changed, only z will remain. The other one we also change from 0 to 2 pi. The one of 0 to 2 pi will be for the psi will be 0 to 2 pi. And the last one will be from 0 to 2, which is the rho. Our rho will now change to 0 to 2. Then we have it to be 4 minus 4 rho sine phi, because that's our y, plus 2z. Z remain the same. So we have it to be rho, the rho, the psi, and the z. The rho, the psi, and the z. So how do we integrate this? How do we get rid of all these things we put into the equation? So the first one, let's first of all integrate this one. Oh, sorry. Let's first of all integrate this with this. So what do we have when you integrate it? Anybody? All we need to do is just to say integral of, let's just keep z. Let's say 0, 3, integral of 4, 0 to 2 pi. So we integrate this one, we have it to be remember there is a row here. We use this row to multiply the bracket. We have 4 row already. 4 row minus 4 row squared sine 5 plus 2z row. Where do we get this row from? I will explain. We got this row from, by the time you substitute, you differentiate this in order to get our dx out. So at the end of the day, by the time you differentiate the x, you equate this one to the x. At the end of the day, you will have one of the row. The last row will be there. So try and take your time, and using our knowledge from calculus, you will discover what I'm saying. That is true. That's what you will have. So in this case now, we can now go ahead and integrate this by saying the row, the psi, and the z. So for the row now, we can go ahead and integrate. We have this. So if you integrate this one, it's going to be 4 row 2 over 2 minus 4 row 3 over 3 u of sine psi plus 2z row squared over 2. The limit is 0 to 2. The psi, the z. So if this is 0 to 2 pi, this is 0 to 3. Remember, you are changing into cylindrical, so that's why we are doing all this. So at the end of the day, when you resolve this one, you are going to have is 0 to 3, then 0 to 2 pi, making 8 minus 32 over 3 sine phi plus 4z. So we can now integrate with respect to the psi. If you integrate with respect to the psi, what do we have? Substitute, all you need to just integrate with respect to the psi, and the z is still there. The z is the last one. So it's going to be 0 to 3. So for us to integrate this one, what do we have? We will have side. By the time you do this, it will give you 0, because when you substitute the value, the pi, 2 pi there, it will give you 0. So you have it to be, this particular one will be 0, but let's still do this one. At the end of the day, you have 8 plus 4z. 8 plus 4z. And if you have 8 plus 4z, what do we have at the end of the day? Then we can go ahead and integrate with the z. Remember the 2 pi? So the z. So by the time I integrate this one with respect to pi, again, with respect to z, rather, I will have it to be 2 pi into 8z plus 4 over 2z squared from 0 to 3. So when you solve this one, you have 84 pi. So these are the little one we can lay our hands on divergence. But let's quickly look at the Stokes theorem. Any question? On Stokes theorem, any question? Any
So-
question, please?
So how did we arrive at 84 pi?
When you substitute your value there, just substitute, add everything together, and let's see.
2 pi.
Remember, you have 2 pi outside to multiply. So how many of us have done something on Stokes theorem before? Anybody?
None, sir.
None. Wow. Okay, let's look at this. Stokes theorem. For the Stokes theorem, in this case, we'll be talking about call. So the formula is, if you want to read more, you can lay your hands on your books. But let's look at the formula. I'll just go straight to the what? Dot the R, which is the same thing as in double integral surface called f the x. So what do we have in this case? They can ask us to verify the Stokes theorem. They can ask us to find the necessity to prove in the Stokes theorem. They can give us the question to prove that this is equal to this in the Stokes theorem, and we'll be using determinants theorem to solve the Stokes theorem. So let's look at this question. Find for me. The question says, one, find the core x, the x, S is the hemisphere, S squared plus Y squared plus Z squared equals to 9, and Z is greater or equals to 0. Upward orientation F into X, Y, Z equals to 2Y plus ZI plus exponential X sine ZJ plus X, plus E exponential YK. That's our F. So if that is the case, how do we resolve this matter? We first of all need to parameterize this function to be able to sort what we have. The first thing we need to do is to look at the condition of this work. So the solution will be The core is saying integral of core f dx equals to integral of c f dr. And c is x squared plus y squared plus x squared plus y squared equals to 9. Equals to 9. Since our y, remember the circle, our z is equals to 0. A circle. Remember, x squared plus y squared equals to r squared, which simply means that we can have, the function is talking about t of 0, 2 pi, right? And our x squared plus y squared equals to 3 squared. So in this case now, we can now parameterize what we have. When you want to do the parameterization, please go and read more about this. I believe you've been doing that. Parameterization is to say that S equals to R cos t. Then our Y is equals to R sin t. Then our Z is equals to 0. You remember, it's more or less the same thing we solved in divergence theorem. All we did is just change where you have R. But what is R in this case? If you look at this one, we solve. Look at the way we put it here. For you to solve this two, you must, this thing is slow, I don't know. Let's just continue. So you must know the parameterization. And it's the same thing as, you agree with me, what is R here from this place? What is our R? I need a response, please.
Our R is 3.
R is what?
R is 3.
R is 3. So we can now write it this way by x equals to 3 cos t. Do you agree with me? Then my y is equals to 3 sin t. And my z is equals to 0. I can take them one after the other by saying, if I want to differentiate, I can say r of t now. R of t is the same thing as the way we did the other time, d the t now, or d the x rather. D the x, comma d the y, comma d the z. So what is d the t? We know it, we can substitute it. We know our half rather. We can substitute it by saying our r prime will be what? D the x of what? 3 cos t, right? And d dy of 3 sin t, comma 0. So if you differentiate this, what do you have? If you differentiate this, what do you have? You have minus 3 cos t sin t rather, and 3 cos t, and this is 0. That's our solution for the differentiation. Then, when you have this, what are the things you need to do from here? Who can tell us? Remember, you have your y. All your y is what? we can go ahead and substitute. Remember, our y says what? Sorry, you remember you have your f rather. That's what I'm about to say. Our f, it says s, y, z, which is same thing as 2y plus zi minus exponential x sine j plus x exponential y k. So I have it already. So what do I do with this? So we substitute f of r. So it's going to be f of our r of t that we have already. So what is, can someone remind us, what do we need to do in this case? Who can help us? I already gave you what we need. All you need is just to substitute.
So I think we'll substitute, we'll carry the f and then the r prime.
Yeah, okay.
And
2y,
substitute.
we have 2. What is y?
Okay, y is 3 sine theta. 3 sine t, sorry.
So what is z?
Z is 0, sir.
So you have it to be 3 sine t.
I think everything will go to 0.
Cos 0 is 1, sir.
Cos 0 is 1.
Okay.
Cos 0 is 1. So we solve that one. Then that is for I component. You agree with me?
Yes, sir.
For j component, what do we have? Exponential. What is x?
X is 3 cos t, sir. Exponential 3 cos t.
Exponential 3 cos
t.
Sine what?
Sine 0.
Sine 0. Now this place will be what?
0.
0 altogether. I hope you are getting it, because I'm trying to be explicit so that when we are solving, when I'm merging everything together, you also reason with me. Now we have y, we have the k component will be what? 3 cos t, right?
Yes, sir.
Exponential 3 sine t. So what do we have? So let's just leave it. Let's now look at what we have at the end of the day. The first one, we have what? 6 sine t, right?
Yes, sir.
Because this one is 1. The second component will be 0. The third component will be what? 3 cos t exponential
3 sine t.
3 sine t. And don't forget, we have here the range. Our t is here is to be what? From 0 to 2 pi, because of complete circle we're dealing with. Now,
Okay, sir.
I can say that here is 0 to 2 pi f of r of t multiplied by r prime of t dt. So we know, don't forget, is component by component. This is r prime of t. So it simply means we'll be taking them one by one to multiply each other. So we are going to have, if you do that very well, you're going to have 2 pi into, now let's do it one after the other. 6 sine t multiplied by negative t, negative 3t, negative 3 sine t. What do we have? Minus 18 sine square t. Do you agree with me? Hello?
Yes, sir.
Do you agree? This is
Yes,
what
Yes,
sir.
sir.
Sir,
I'm
can we
just
bring it together? Can we bring it together, sir?
okay. No problem. Let me do that for you guys so that you understand what I'm doing. So it's going to be minus 3. The first one will be what? For r prime. Okay, let's write the one of. Let's write this one.
Minus 3t.
Okay, minus 3
T.
sine t. Okay. So let's first of all write f. F is the first one here. F will be what? 6 sine t, comma 0, comma 3, plus t, right? Exponential 3 sine t. Dot minus 3 sine t comma 3 cos t comma 0. Do you agree?
Yes, sir.
Yes, sir.
Oh, okay. Now, we can now bring them together like you said. Let's match them together. What do we have? Component by component. Component this with this. Component this with this. Then component this with this. Everything dt. So is the integral of 0 to pi will give us what? 6 multiplied by negative 3. Negative 18
Minus 18.
sine squared t. Plus 0 multiplied by 3. 0. 3
0.
multiplied by 0. 0. Everything dt. Are we together?
Yes, sir.
Are we okay now? But recall from the way we solve, we have a standard called standard half angle. You remember? So it will give us the definition of sine squared theta from half angle is what? 1 minus cos 2t, because we are dealing with t now, not theta. Go and check your trig function. So that's where I pick it up from. So if you check your trig function, you will, the definition of sine squared t or sine squared theta will give you this. So, and here I have minus 18, I can take it out by saying 0 to pi. Then what do I have here? Remember the definition already is this. So I can put my definition in by saying y minus cos 2t dt. Y minus cos 2t dt. So what do we have? When you integrate this one, what do you have with respect to pi? I can take 1 over 2 out. If I take 1 over 2, I'll have minus 118 over 2. Then let's integrate this one. If you integrate 1, what do you have? You have t minus. If you integrate minus 2t, you have minus. Minus times minus will be plus 2, 1 over 2 sine 2t, 0 to pi. So you have -9. At the end of the day, when you substitute this into this, you have pi minus 1/2 sine 2 of 2 pi. So at the end of the day, if you do it very well, you have -18 pi. Any question, guys? There was a guy that I always asked for, are we doing Stokes theorem? Stokes theorem. Are you here? The guy is not here. Here is Stokes theorem, or you'll be asking for, and you are nowhere to be found now. It is well. Anyway, does it make sense to you guys?
Yes, sir.
Makes sense.
Okay, let me give us one question again. In this case, there's this question talking about triangle ventures. Always mute yourself. So let's look at this. Find integral of close of the R, where your C is the triangle. C is the triangle. With vertex 1, 0, 0, and 0, 1, 0, and 0, 0, 1. So when I say C is counterclockwise. C is counterclockwise view. Counterclockwise view. So we have it to be from f of s, y, z equals to s plus y squared I plus y plus z squared j plus z plus x squared k. So, and the solution will be integral of f dot the r will be integral of cos, remember it's cos f dx. So how do we solve cos df? I've explained it to Ross several times. We've done it together. And I believe you'll be able to solve it. So how do we solve this? It's the same thing as for f equals to ijk, which is d ds. What's the d dx of I? X plus y squared, right? let's say j. For j, we have d dx dy of y plus z squared. K, d dz of z plus s squared. So what do we do in this case? We can remember that for us to solve this, we have plus, minus, plus. You remember? So always identify them. For those of us coming for the first time, let's look at this together. So we have it to be I. Let's say we are solving for the I. You're taking I. Now, what happened to this? Everything here will paralyze. Remain what? D dy of y plus z squared. Then k will be d dz of z plus s squared minus j. If you pick the one of j, what will happen will be d dx s plus y squared d dz z plus x squared plus k will be d dx s plus y squared and d dy y plus z squared. So all this is important for you to be able to solve the problem so that you will not mix it together when you are asked to solve it. Now, it simply means this multiplied by differentiate this one and differentiate with respect to this. That's the meaning. That is, I will be differentiating d dy with respect to, I will be using s plus z plus x squared, differentiate it with respect to y. If I have any value there, I will differentiate. If not, it turns to 0. Remember the principle. So let's look at I. For I now, we have d dy for this. There's no y here. Everything here turns to 0. Minus what we have here, 2z.
Minus 2z.
Minus 2z. Thank you. So the next one will be minus j. If you do the x, you have 2x. If you do the z, minus 0.
That is 2x.
Yes. Thank you. So, plus k. Let's look at the k. It turns to 0 minus 2y. So you can see that without this now, we may not be able to solve it. So you have to look at it, minus 2zi minus 2xj minus 2yk. So based on the principle of what we are used to, we can begin to differentiate them one by one. We know our P, we know our Q, we know our R. You remember the way we did the other time? It still boils down to the same thing. Remember when we solved this one, we said Pi plus Qj plus Rk. So which is the same thing as when you have integral of this, integral of core for f dot the x to be equals to integral of d. That is, I know my p is equals to what? I can substitute them. I can just say that, just look at it. I can just say minus, because minus, everything here is minus p, let's say d dx minus q d dy do we have plus there? Let's say plus r dA, or let's say r dA, or whatever we put, because we only have to solve the order. So from here, we can also put r, let's say plus r, let's say dA. RDA. If you put it RDA, what do we have? But if you don't put it that way, it's still the same thing. But what we need to do is to first of all resolve, because we are still going to resolve, we want to resolve this D first. Now, if you look at this, we are given this x plus y plus z, everything equals to 1. So I can make z equals to 1 minus x minus y. Right? Is it possible, please?
Yes, sir.
Yes, sir.
So if it is possible, then what do we have to say about this limit now? About the rest? We can also look at it. Call this one. I can call this one. Probably I should not use, okay, let's say Z. But Z, our Z in this case, still boils down to, if you differentiate with respect to X, what do you have? If you differentiate with respect to Y, what do you have? If you differentiate with respect to Z, what do you have? So in this case now, we can say that don't let me call this one Z. Let me just call this one. Let me just say, let's say I just add, let's say G of these G. Let's call them G. Now, if I put this, say, if I said G of X, comma Y, in this case now, our Z is equals to 0. That's the meaning. So if you said that Z, G of this, what do we have? G, the X, sorry. The G, the S is equals to what? Differentiate this with respect to X. What do you have? -1. If you differentiate the same function with respect to Y, what do I have? Anybody? What do I have?
-1.
Minus y.
-1. Thank you. Now, if I add -1, I have -1. So coming to this particular integral.
Well, sir, excuse sir.
Yes.
So if we say z is equals to 0, well, I think it should be, then it should be x plus y equals to 1 first before.
No. What I'm saying is, okay, don't let me say z is equals to 0. dz.
Okay.
dz, the g dz equals to 0 because there's no z in this function. Are you getting it?
Okay, sir.
There's no z in this function that we are doing, they are working on. So if you now substitute, if you differentiate z in this case, now there's no z, like the way we did when we are doing the call, when there is no particular variable that you are differentiating with respect to, it turns to 0. Now, if it is turns to 0, it simply means anywhere I have the z, I will put it to be 0. That is the meaning. But in this case now, we have this integral function. But for the integral function we have, let's substitute. Look at it. I have integral of this. I will have minus, my minus p is what? From here. Minus p is what? Sorry. This is our p, right? This is our q. And this is our r.
Okay, sir.
Now, our p is what? Negative what? 2z. Then what is the g, the x is negative 1. Then minus, what is the q? What is the q? Our q is minus 2x. Then what is the y, the g, the y? Minus 1. Am I right? Minus 2y the a. Remember, there's no z. That's why we don't put it. We don't have the issue of z in this case. The z is 0. So now, in this case now, what do we need to do? Let's open the brackets. Minus times minus, positive, times minus, negative. 2z. Minus times minus, positive, minus, turns to 2x, minus 2y dA. So we can now go ahead and substitute this back into our z. Remember we have here, remember from here, we said z equals to 1 minus x minus y. But the z is equals to 0 from this function. Don't forget. So anywhere you see z, substitute those functions back into it. So what do we have? Integral of minus 2 of 1 minus s minus y minus 2x minus 2y dA. So now, in this case, what do we do? Open it, minus 2 plus 2x plus 2y minus 2x minus 2y dA. So this go with this, and these go with this. So we are left with what? Minus 2 dA. So we are left with integral of the double integral minus 2 dA. So which implies that minus 2 integral of the A rather. So at the end of the day, when you have this, what do you have? Anybody? How do you integrate this? Hello? Minus
Yes,
2. When you integrate the A, what do you have? You have it to be A. Do you agree with me?
yes, sir.
So when you integrate A, what do you have?
You have E, sir.
You have what?
When you integrate the A, you have A, sir.
So you can tell when you have a constant, it's still going to be constant. Look at it very well.
0.
No, integration can never be 0. Don't forget. So what will it be?
Minus 2dA.
Minus 2. No, you can't be the A again. That's you are going back to the integration.
It's minus 2.
Is minus 2. Minus
Yeah.
2 what?
Minus 2 integral. Sure.
Go and check your notes. You will see at that point when you are solving it, what does it equal to?
Integral A.
Yes, I know it's integral A. You are right. But where A is what?
A should represent the small piece of the area, Nabi, of the triangle.
A is a value.
Yes. It represents the area of the triangle.
What is it? So find out. A is a value. Somebody is very close to it already. You are saying it. So you have 1 over 2. At the end of the day, is going to be minus 1. So you guys, you said you are writing next week.
Yes, sir.
Okay.
Yes.
Next week, when?
Friday, sir.
This Friday. Okay. What I will do is I will
Yes, sir.
share my video. Let me stop sharing.